We're going to look at some problems about turning, or making turns, and it's important to know when you make a 90-degree turn or a 180-degree turn or a 360-degree turn, what direction you might end up facing from where you started. And I think the easiest way to think about this is to draw a circle and cut it in four. So this is sort of like a circle that you might put on a graph. If you start, let's say you start here and you're looking this way. Start right here. If you turn 90 degrees, you end up 1/4 of the way around the circle. So that's a 90-degree turn. And you'd be facing that way. So if you started facing, what would this be, east? And you turn 90 degrees, and this is actually counterclockwise. It's going the opposite way a clock would move around the circle. Then you'd end up north. If you turned another 90 degrees, which would be a total of 180, you'd end up facing west, which is the opposite way you started. So 180 degrees, you turn the opposite direction. You turn another 90 degrees, a total of 270, now you'd be facing south. And if you turn another 90 degrees, a total of 360, you'd be right back where you started, facing east again. So this is the basic idea behind a lot of these problems. Let's look at a few. The first one says Leela was traveling east. And right away, I just want to make a diagram of this. So I'm gonna do my compass here. East, north, west, south. So Leela was traveling east, so she's pointing in this direction. At the light, she turned 90 degrees to the right. Now, here's where you sort of have to put yourself in Leela's position. If she's facing this way, right to her is going to be down this way. So she turns, it says 90 degrees to the right. So now she's going that way. And she traveled 1 block to the next intersection. At the intersection, she turned 90 degrees to the right again. Again, you kind of have to put yourself in her position here. And it might help to turn the paper around so the arrow is pointing up. A right turn from where she's looking here would be back this way. So she turned a total of 180 degrees to the right. So you should realize that she'd be facing the opposite way from when she started. The question then finally is, what direction was Leela traveling? And the answer would be west. All right, let's look at another one. This next problem is a little bit tricky. It says, as Elizabeth ran each lap around the park, she made 5 turns to the left and no turns to the right. What was the average number of degrees of each turn? So basically she's going around in a circle, except there are turns in it, so the track she's running on must look something like that. There are 5 sides to it and 5 turns. Maybe she starts here and turns left and then turns left, turns left, turns left, turns left, and she's back to where she started with. It might not look like that, but that's how many turns it has. The question is, what was the average number of degrees of each turn? Now, if she had a square track, each turn would be 90 degrees. And if she went all the way around, she'd go 90, 90, 90, 90. That's a full 360. And she'd be back where she started. It's easy here because we know what a 90-degree angle is. On this one, we're not sure of the shape of the track, but the average degrees we can figure out pretty easily. All we need to do here is realize that she's still going around a full 360 degrees. So to figure out the average number of degrees in each turn, we're just going to divide it by the number of turns. 360 divided by 5. Over here, we knew these were 90, but 360 divided by 4 turns equals 90. And 360 divided by 5, I think, is 72 degrees. You can check that on your calculator. So that's how we do that problem. I've got one more here. It says Candace and Owen were both facing east. So, all right, I'm going to draw my diagram here. Here's east, north, west, south. So they're both facing this direction. Candace made a 270-degree clockwise turn. So 270 is one of those numbers that should stand out to you, just like 90 and 180 and 360. It's 3 90-degree turns, and she's going, it says clockwise. So if she starts here, 90 degrees is going to make her turn that way, and then another 90 degrees is going to make her turn that way, and then another 90 degrees is going to make her turn that way. So she would be facing north at the end of that. It says, while Owen turned counterclockwise to face north. So instead of turning down this way, the way a clock would go, Owen turns 90 degrees, sorry, Owen turns to face north. Well, one turn, 90 degrees, is all it's going to take. And the question here, I kind of gave it away, was how many degrees did Owen turn? Only 90, just one turn. So those are some problems about turns.